All right, guys, we have a piecewise function here, and what we need to do is treat each of these, or we need to look at each of these pieces as separate lines, okay? So this one is a totally flat line going to the left, has a solid dot right here at the x value of 3. So what does a line that goes all the way this way, a totally flat line that crosses the y-axis at 2, what does that look like? That's the equation y equals -2. Now, of course, that line doesn't extend all the way that way. It has an endpoint. It's a solid dot at -3, okay? But that is the line right there, y equals -2, but we're only looking at this piece of it. So that would be the condition, x being less than or equal to -3. Here's a -3, it's to the left of -3. We'll get to that in a little while. But right now, let's move on to this next line. This next line, in order for us to write a line, we need a m value and a b value, okay? So it's an open dot, and it's going down this way from left to right. It's going down. It's another open dot. And as you could see, the slope on this line, because in order to write an equation, you need an m value and a b value. Now the m value is how much it rises over runs, and from here, from this dot to this dot, it drops 1 and it goes over 1, right? It goes down 1 over 1. Or you could go from this one to this one, down 1 over 1, down 1 over 1. Even if you were to go from this one to this one, it goes down 1, 2, 3 over 1, 2, 3. And if you did have -3 over 3, that becomes -1 anyway. Your slope is -1. Okay. Now, what's your b value? Where does this line cross the y-axis, the y-intercept? That's the value of 4, so the b value is 4. And the equation would be y equals -1x plus 4. Okay, that's y equals mx plus b. Now, the condition, you're not looking at the whole line going this way forever and that way forever, right? It doesn't continue going forever that way. It doesn't have arrows going that way forever. It's an open dot here and an open dot there. So technically your condition is from this x value of -3 to this x value of 0. So this line, you're only looking at the piece of the line from -3 on the x to 0 on the x, from here to here, right? Let's look at the last one. I'm going to do the last one in green. The slope is from here to here. It goes up 1 over 1, up 1 over 1, up 1 over 1. So the slope is +1. The slope is +1. And the b value, where does it cross the y-axis? Obviously, it crosses at 0, the y-axis. And it is a solid dot right there. Solid dot right here, going this way forever. Has an arrow. So it crosses the y-axis at 0. So what is this green line? What is the equation of this green line? It's y equals 1x plus 0. Now, you don't even need to write the 1, and you most definitely don't need to write the 0. You could just write it as y equals x, okay? Anyway, we have our 3 equations, and all we need to do now is write it in the form of a piecewise function. F of x equals, put this bracket, and let's begin. From left to right, we have this blue one, and it says y equals -2. So that's the equation of this blue line. Here's the y equals, I'm just going to put my -2 up here. Now, what is the condition? Obviously, you don't have the whole line. You have the line from this point to the left. Now, what is this x value? Because the condition's always with your x value. This is the x value of -3. The line exists at -3 and to the left. To the left is less, to the right is greater. So it exists at -3 to the left. So it exists at -3 and less than -3. So my blue equation is really y equals -2, y equals -2, and then we say if x is less than or equal to -3, okay? Again, it exists at -3 and to the left. Solid dot means a solid line underneath your inequality. If this would have been an open dot, I would not have a solid line underneath my inequality. Let's move on to this red line, or at least the piece of this red line that normally would go forever in both directions, but we're only looking at it from here to here, which is a condition from -3 to 0. Anyway, again, you want to write this red equation in this piecewise function. So here's the y equals, right? Y equals, here it is, y equals. And over here, we're going to write -x plus 4. Let's do that. -x plus 4. Okay, now we need the condition. We need the condition. And what is the condition? Well, we mentioned that from here to here, where is that on the x values? It's from the x value of -3 to the x value of 0. So how do we write a compound inequality from -3 to 0? You just write down -3, write down 0, put the x in the middle, and less than symbols. Once again, we're going to say if, and you put -3 on the left, 0 on the right, x then in the middle with less than symbols. Okay? And why did we just use less than symbols? Because these are both open dots. An open dot at -3 and an open dot at 0. So open, no solid line underneath it, at -3 and at 0, x in the middle. Moving on to the last line that we want to represent. This last line is read y equals x. So we have y equals, and over here we're just going to put x, and the condition if what? Well, where is this line at? Is it existing at the x value of -3? No, at -2. It starts existing right here at the x value of 0, and it is a solid dot. And is it going to the left, which would be less than, or to the right, which would be greater than? It's going to the right side. So if x is greater than or equal to this x value of 0, x is greater than or equal to the x value of 0. Okay, and there is my piecewise function. And if you do this without looking at your multiple choice answers, that's the best option to do. Do that, and then once you have this completely done, then you could look at your multiple choice answers, and you'll see which one is the correct one, which here it is. F of x equals -2. There's the -2. If x is less than or equal to -3, there you go. The next one, f of x equals -x plus 4, -x plus 4. If you have a compound inequality with x in the middle, -3 and 0, -3, 0, x in the middle, less than symbols, we're good. Last one, x, if x is greater than or equal to 1, x if x is greater than or equal to 1, this is the correct answer. I hope this helps on this piecewise function. So right here we're going to be pretty much applying distributive property, but of course we need to know how to multiply square roots and also how to multiply i's, imaginary values. And let's see how this works. It's pretty easy. Let's distribute one at a time, right? There's two things here, right? You have the negative square root of 5 and you have the 2i. There's two items. It's a binomial. Let's distribute one of these at a time. So negative square root of 5 times square root of 3. What is a negative times a positive? It's going to be a negative, so we're going to write down negative. And what is the square root of 5 times the square root of 3? You could actually put those together underneath one single square root. That's the square root of 15. Now, it would have been great if this would have been the square root of 16, right? Or if it would have been the square root of 25, but it's square root of 15, we're going to leave it like that because we cannot simplify it. Anyway, maybe we shouldn't even think about simplifying yet. But anyway, we still need to distribute the negative square root of 5 to this other term over here, negative I, okay? So a negative times a negative is a positive, so let's put a plus right here. And a square root times a variable, you're just going to put the variable in front and then the square root term second, all right? So if it were a square root of 5 times x, you'd put x square root of 5. Right here, it's square root of 5 times I. It's simply going to be I square root of 5. Okay, now let's distribute the positive 2i. Positive 2i times the square root of 3. Well, think of it this way. It's kind of like if you had 2x times y. You would just put it all together, 2xy, right? So even if you were to think of it, what number's in front of the square root? There's a 1, okay? So if you go 2 times 1 is 2, and then you got the I, and then you got the square root of 3. Maybe don't even put the 1. Again, let's just repeat what I just said. If you had 2x times y, what would it be? It would be 2xy. So right here, 2i times the square root of 3 is going to be exactly that, positive 2i square root of 3. Okay, you just put them together with multiplication. After all, this is multiplication between the 2 and the I, and we want to multiply it with the square root of 3, so it's just a question of rearranging it. 2i square root of 3. There it is, 2i square root of 3. Last but not least, positive 2i times negative I. A positive times a negative is a negative, and 2 times, there's no number in front of the I, so that's going to be just a 2, and I times I is I squared, okay? And let me put this I squared in green because we know that every single I squared we need to replace with a -1. So -1 times -2, that is going to end up being a +2. So could we combine any of these three radicals? We cannot. They're not like terms. Like if I would have had the square root of 5 and then plus the square root of 5, yes, I'd be able to do that. But these are completely different radicals. You got the square root of 15, square root of 5, square root of 3. They're all different. So that's technically your entire answer, right? Negative square root of 15 plus I square root of 5 plus 2I square root of 3. That is your answer right there. The answer could be written differently. They could have the 2 out in front. They could rearrange it. This one could be before that one. It doesn't really matter. This is a multiple choice test. You should see that the answer is right here, this green one. Negative square root of 15 plus I square root of 5 plus 2I square root of 3 plus 2. That's exactly what we have here.